In this video, we're going to see how to actually train a GAN. We're going to use StyleGAN2 ADA, which is the latest from NVIDIA on the ever-popular StyleGAN. I'm going to train it for images of my own. I'm going to show you some examples of what I was able to do, both how I collected the images. I collected some images of fish just using Flickr, and I was able to generate some really cool, realistic results that you can see here, just using the StyleGAN2 ADA, and ADA lets it make use of sets of smaller numbers of images. So I'll show you some of the things that I did. We're going to make use of a Lenovo ThinkStation P920. This computer has two Quadro RTX 8000 cards in it. It's two GPUs and also two Intel Xenon processors. So this machine is an absolute beast in terms of processing power. GANs are crazy hungry for compute and GPUs. So you don't necessarily need dual GPUs, but you need one high-end one. Most of the training that I will show you went for nearly a day with dual GPU, and to get it even more high resolution, I dealt mostly with 256 by 256. If you wanted to go 1024 by 1024 on dual high-end GPU, that would be more than a week of training. We'll get into exactly how much. There's some other things that depend there as well. So let's look at how you can set this up. I like to use a Docker image that I created, so I'll show you how to get that up and running. In Linux, I mean, Linux first really on this kind of stuff, because either you'll be running on a cloud or you'll be running on some sort of high-end workstation and most of these high-end workstations, they come with Ubuntu or something pre-installed because you just want to get right to the core of how to do it. Also, definitely want to thank Lenovo for lending me some of their very high-end hardware to try this out and to demonstrate this on my channel. On any GAN project, the first thing to do is just think about really what you're trying to do, because that will determine the types of images that you need to gather. And not just what you're creating the GAN of, but how you're going to curate these images. For example, here you're looking at alien landscapes. And what I did here is I basically just grabbed a bunch of 1970s art for comic books, and I trained a GAN on it. There was about 30,000 images, but I really didn't separate this out in terms of spaceships or aliens or other things. So it seems like the GAN learned the best just on landscapes. And I'm showing you the landscapes here. If I switch over to just random GANs that are not landscapes, you can see it gets a lot more wild and crazy. It's clearly nailed sort of the 1970s style of comic book art, but it is not really producing anything that is really, really consistent. So here, I was able to at least give it the style, and it was able to figure out the style, but it's not producing quite as concrete as I would expect, unless I focus on landscapes like I had done previously. Now, NVIDIA went very, very curated with faces, and you can see the classic GAN faces here. All the images in this data set were faces of people, and generally looking forward, and cropped so that their eyes were approximately in the same spot, things like that. That is a highly, highly curated list without a lot of variety. They're all people. They're different races and ages and genders of people, but they're still all people. They all have two eyes. They have a variety of skin colors, and this is a very curated list. I also went very curated with the FishGAN that I created. And for this one, I basically just went out on Flickr using my Python image data utility that I have a link to. And I have videos on that utility as well. You basically just give it keywords and it goes and pulls down a bunch of images for you from Flickr. Now, the fish, though, I did have to spend considerable time going through the 3,000 or so fish that I had and eliminating about 1,000 of them that were either fish that were cut off or not pointing in the right direction, or there were cats in the image looking at the fish. Generally with a GAN, when you teach it on multiple things, so if you taught it both cats and dogs, it will do some dog cats, but it will tend to not learn the cats or the dogs as well as a GAN that didn't have to divide up its attention span. Then I created a GAN on Minecraft, and this is an interesting technique. I'll do a video separately on Minecraft because it let me basically take video. So I used video. I basically just started recording my screen and just ran around in Minecraft like a crazy person, like you can see here, and let basically a whole 24 hours go by. So there's dark, there is brightness, and essentially the GAN learned to generate these images that you're seeing here. Now these are a bit abstract, but they're still very, very, very much Minecraft. I kind of want to do something else with images. I think it would be really fun to, I don't know, take or images from video, I should say. It'd be very interesting to go through I don't know, Star Trek, if I can do that without getting sued by Paramount, and say, separate all the video into individual stills, and then run another neural network on that just to identify the ones where it's pretty close to a headshot of somebody and crop those out. So I don't know, I could almost do a StyleGAN on Star Trek Aliens or something like that. I don't know, just the beginnings of an idea there. And then the GAN miss. So I took holiday and Christmas images from Flickr. I did no curation on this whatsoever. I wanted to see what GANs would do if I just threw everything imaginable at it, but yet still in a high level domain. So you can see this is very, very abstract. It's doing Christmas lights, you can see some Christmas figures, other various things. So these are just some of the different ways that I went about getting GAN images, and I will probably do other videos talking about each of these, the challenges of each of these separate. All right, here we are in Ubuntu. I've started up a web browser and I went to Docker Hub and I'm at Heaton Research StyleGAN2 ADA. I'll put a link to that down in the description. This is the Docker image and I give you a lot of instructions in here. Make sure that you refer to these instructions and not necessarily try to type exactly from the video. I'm going to copy and paste from here, because these things tend to change as we move into the future. So I will update this as I notice other things that might change, or if I discover ways to make this work better on WSL2. And by the way, if you're interested in a specific tutorial on WSL2, let me know in the comments, and I will be more than happy to go down that path. So I'm copying that command. Make sure you have Docker for NVIDIA installed. There's plenty of videos and tutorials on that. I am going to now basically paste this command, but I can't run it exactly like it is there because I have to put my username into there. Notice this Docker command. We're running NVIDIA Docker run IT for interactive terminal. I'm mapping the user so that the user I'm logged in with has the same permissions to files as the user that's running in the host operating system. I'm mapping one volume here. So instead of username, I'm going to put in my username, and my username is Lenovo because I am on their P53 laptop that they provided for me. The big computer, the P920 ThinkStation, is busy training another GAN, so we're using this one. It looks exactly the same, except this is one GPU as opposed to the other one is two, but I'll show you exactly how that's set up. Then I map in my GPU, and then this is the name of the Docker image, Heaton Research StyleGAN2 ADA, and I'm going to run a bash terminal, so bin bash. We run that, and this comes up. By the way, if you get any sort of an error, I suggest restarting. I actually had to interrupt my recording and restart because I was getting a similar sort of error. Often happens when you're doing this low-level training with GPUs. So here we're in the TensorFlow provided Docker image that I made some changes on top of just to make things a bit easier. The first thing that we're going to have to do now that we are actually in this Linux environment is we need to convert the images, so the images of the fish, if we're doing my fish example, into TFRecords. TFRecords are a binary representation of training data that TensorFlow uses for efficiency, and StyleGAN2 ADA is all based upon TensorFlow. So I'm going to go ahead and open up my files, and you'll see that I have two directories, data and data sets. Since I have mounted that as /mnt, in Docker, I should be able to see those. So data is where my data sets go. Images, fish, final. You can see those there. If I open it up, it's just a whole bunch of images of all these fish that I downloaded from Flickr with their SHA hash names so that to prevent collisions from two of the same image. And if I go into my Docker over here, I can see that directory by doing ls/mnt. So mnt is where my home directory is mounted, so /data. And if I run that, I should be able to see those. So there's images, fish, final. So that's going to really come in handy when I need to run this next command. And by the way, the output of this is going to be going to this data sets directory. These are, now you can see images, fish, final. I've already run this once. And there you can see all the TF records that were created. You can see these are fairly large files, up to around 1 GB or so. So this is what TensorFlow will convert these into, and this is the input into StyleGAN2 ADA. So let's go ahead and convert our image data. These are the commands you need to run. First, just that cd command. That is due to the way that I set up this Docker image. This moves you into the StyleGAN2 ADA. This is where I basically just copied the NVIDIA GitHub repository. And you can see there it is. Those are the Python files that actually run this. Okay, so the next thing you have to do is run this dataset tool that's going to convert them. We're going to copy that, and I'm going to paste it into here. And Python dataset tool, create from images, mount /datasets/fish. So that's the target. That's what it's being converted into. And I am going to just call this images fish final. And then here, mount data. This is where the output, this is where the input is coming from, all those individual images. Images fish final as well. Now, the thing I'll say about this, the error checking in the NVIDIA TFRecords converter is not great. You can easily end up with corrupt TFRecords things. The things to really, really look out for, I have listed here. Basically, you want to make sure that all the images are the same color depth. You can make them grayscale, you can make them color, but they all have to be that way. Then also make sure they're the same resolution. So 1024 by 1024, 256 by 256, they're basically powers of 2, and they have to be square. The other thing too, if you're using PNGs, don't put transparent images in there. Now, that's one of the utility functions that my Flickr downloader does. I basically remove transparencies, I convert all the grayscales to color, and I try to make it as TensorFlow compatible as possible. But if you're getting these images from some other source, then you might have some of those issues in there. And it'll just throw Python errors at you. It's not going to actually give you an error message. There's a few error messages in there. So let's go ahead and run that, see if I actually got that all correct. Yes, and now it's converting. These are 256 by 256 images. If it's 1024 by 1024, then it's going to take longer. By the way, this is one of these error messages that I mentioned. If it says axes do not match array, this means basically you have an image in there that is not of the same either dimensions or color depth as the others. So I did want to actually show you what this one looked like. This was from a first version of the fish images where I basically then had to do some more manual processing, basically with Python scripts. I wish there was an easier way to deal with this particular one, but those images have got to be standardized or you will get this exact kind of an error. Okay, I am not going to show you the resolution for that. That was basically just writing a Python script and standardizing it. That same Python script, by the way, is in my Python image data. So I've got scripts in there that basically run over all of the Python, all over the images with Python and standardize. It requires some manual tweaking, but this is part of the fun of computer vision. Okay, I have fixed that behind the scenes. So let's go ahead now and actually train it. I don't have to do that same cd command again because it's already in there. We are going to run Python train this, and I am going to paste this one into here. Now, let's pay attention to what's going on here. This is Mount's data set. We don't want to just do fish. We want to do images fish final. Mirror just means do you want to flip the images back and forth. And for the fish, that's perfectly fine to do. That just gives it twice the amount of training data for free. That's how many K images you want to train for. Usual values for this are 3,000 up to 25,000. If you do 25,000, this thing is going to train for a while, depending on how many GPUs you have. This page here shows you some of the training times reported by NVIDIA for different K images. This is on the StyleGAN GitHub repository. You can see with just one GPU, this can take a long time. They trained it all the way up to 8 GPUs on a workstation. It's good to be NVIDIA. They had DGX1s for their researchers to test this out on. So I'm just going to do this with 3000. This is the out directory. We'll look at that in a moment, the results directory, and we are going to use ADA to augment it. Always use ADA unless you've got just a ton of images. But if you've got less than, I don't know, I would say 90,000 images, 50,000 images, definitely use the augmentation. I'm going to go ahead and run this. This will go on for a while. It has to compile its CUDA kernels. This is pretty advanced code that NVIDIA has, and it's all open source. You can look right at their Python source, which is awesome. Now, while that is running, because that will run for over a day, let's go ahead and look at that results file that is going to create for you. If we go back into Home and Results, here you can see some of this is the one that's training. I am going to go ahead and open up, let's see, let's look at this one. This is actually one that I trained on Christmas images. And this shows you kind of what this looks like. So these are holiday images that was trained on. And the file that you want to look at here is this log.txt. That shows you what is basically running in that other window. And it's going to go through all of this, print out all of this, and this part here is what you're going to want to pay attention to. It's going to make the first network snapshot and tell you how long it took, and tell you the FID. FID is essentially the error metric that they're using. That will get lower and lower and lower. Something below 10 is really good, unless you have a really highly curated image set with very similar sort of images like they did with the faces. You're gonna probably see something around, I don't know, 20, 30 in that range. And they'll be a little abstract, but maybe not horrible. So what this does is it trains. These ticks are how, basically every 50 ticks, it's going to save a snapshot and it's going to reevaluate the error. So here you can see the FID fell to 151. They're also reporting how long it's been going. So it's been going for 4 hours at that point when we saved the first snapshot. This is how many seconds for a tick. So you can calculate approximately how long until the next snapshot is saved. And then this is how many seconds per K image. You can calculate how long it's going to take to run the whole thing. GPU memory is critical. This is telling you that it's taking this amount of memory. If you run out of GPU memory, this thing will just stop, and that's it. So if you are running into memory issues, either decrease the resolution of your images or decrease the size of your batches during your training. And then you can possibly get by. And it keeps going and going and going. This one trained all the way for 3,000 K images on a 256 by 256, so this would be pretty similar to the fish. It took about 2 days and 17 hours. Welcome to GAN training. That's with a single GPU. 2 GPUs would have pretty much cut that in half to about a day and 8 hours or so. Now, as this thing is going, there's a variety of files being created. Fakes basically show you, I'll open up the last fakes. This will just show you some of the fake fish that were being generated. Or I'm sorry, in this case, fake Christmas ornaments. This was a very abstract data set, so they don't look nearly as good, I think, as the fish. I threw everything in the kitchen sink at that data set. And then there's also all these pickle files. These pickle files are your neural networks, and you can literally take those, and I often run these in Colab, and I'll give you a link to a Colab project for the fish that basically it just took the last pickle file that I had here, or the pickle file with the lowest error, and I can generate those right out of a browser. You don't even need a GPU in that case. You can use Colab's GPU, although a GPU is definitely needed to run this. Reels basically show you just kind of a similar image of the reels that were used to train it. So a neat animation that people do sometimes is they'll take all these PNGs here and basically animate them, showing the GAN slowly get more and more precise as it trains. Okay, so at the end, I am left with the neural network that can generate the fish, like you see here. Thank you for watching this video, and if you're interested in artificial intelligence, machine learning, and all things AI, then please like this video and subscribe to my channel.